Okay, hey everyone. Welcome back. Good morning. We have like 2 minutes and then I'll get things rolling for today's Wednesday meeting. But overall, hope you guys are doing well. And just get comfortable and we'll get started in a bit. Hey Cordy, good morning. And hey Brandon, good morning. McKenna, welcome back. Kylie, Angel, good to see everyone. Hey there, good morning.
How you doing?
Good.
I'm gonna start bringing you coffee.
Oh yeah, sometimes I need it. Once I get home, I usually get it, but sometimes in the morning I'm in a rush, so.
I love a good coffee like 3 p.m.
Yeah,
It's my favorite.
that helps you get through it, yeah. I just bought an actual coffee maker. I was just, for the longest time, buying just iced coffee and stuff, so now I'm making my own roasts.
That's cool.
Yeah.
My dad's super into he's got this big espresso machine.
Oh, yeah. Mm-hmm.
His pride and joy.
Yeah, that's the next frontier. I mean, I'm a little intimidated to get into the espresso stuff, but I know that I want to do it eventually because that's like really good. Hi, Sebastian. Good to see you. Okay, we're almost ready to go. Hi there. Hey. Chase, welcome back. Claire, Zoe. Okay, everyone. So we're pretty much at 10 a.m. So thanks again for being here, all you guys. And let me just kind of orient ourselves to what we're going to talk about today, and we'll go through the lecture notes. So we're trying to wrap up and finalize our lecture series on the metaphysics of time. We have just a couple of remaining points to talk about from Ted Sider's article, and then we'll try to open up the discussion of David Lewis, and then that'll cap off this particular unit of the class. On Friday, we'll start on to the last, well, not the last topic, but one of the last, which is philosophy of mind. And good morning, everyone. Welcome back. It's always good to be with you guys. Thanks for your attendance, and make sure to check into the chat with a comment at some point just to leave the attendance record there. Okay, so I'm just going to do a quick little crash course review of some of the points we've covered. We started with the philosophy of time by looking at the writings and the results of Albert Einstein. Einstein's theory of relativity definitely revolutionized the modern day understanding of time and space, changing it from what we had thought we knew from the work of Isaac Newton. So his main claim to start is, well, it's a scenario. He says, suppose that a railroad has two different lightning strikes that occur at separate points of the railroad. Call the 2 points A and B, A to the left, B to the right. Say that they happen simultaneously. What does that mean? He says, in order for us to give the right kind of scientific definition of simultaneity, we have to be able to perform some kind of test that could verify whether or not the two events were simultaneous. So what would be the test by means of which we could check for simultaneity? He says, let me suggest this. Measure the distance between the two positions A and B, and designate the midpoint M, which is intermediate between A and B. Let's place a motionless stationary observer there at M, the midpoint, and if this individual standing at the midpoint sees the two lightning strikes occur in one and the same visual perception, then given that the speed of light is constant and fixed, we can use this situation to deduce that the two events emerged from their origin points at the same time. Because if the two light rays have traveled an equal distance, moving at the same velocity, and arriving at a common endpoint M at the same moment, then that implies that they departed from their two respective origin points at the same moment. But that's only in relation to the initial observer who's stationary at M. If we take a second observer who's passing through the scene with velocity v, moving on the train, as they surpass the midpoint M prime, which momentarily aligns them with the initial observer who is doing their observation at M, the second observer will not remain at rest at the point M prime and is carried with velocity v to the right towards B. And so therefore, because the speed of light is the same from B to the observer as from A to the observer, given the fact that he's running away from A and closer to B, the two light signals won't reach his eyes at the same moment, and thus he will see it happening in the order of B first, subsequently then afterwards A. And this is the sort of deep and puzzling result which implies that the same two events do not have any objective linear ordering. In one account, they're simultaneous, in another, B is first and then A. And if we imagine a third observer whose direction is in the opposite direction of travel, towards A and away from B, then if the same person surpasses the midpoint, whilst the other two are aligned along it, that individual will see A happen first and subsequent to it B, because of the same phenomenon of the ray of light having to travel different distances at the same speed to reach the individual's visual system. Okay, and so after that, we talked a little bit about some further consequences of this theory. We talked about the concept of time dilation, which can be explained via the case of a light clock. And we also talked about the twins paradox, which is a further implication of time dilation. If two different observers were moving at different states of motion and velocity, one accelerating very fast, the other one remaining relatively at rest, then in that case, the one that's moving fast through space is going to surpass fewer duration of time than the one that's at rest. So basically, fast-moving objects through space pass through time slower in comparison to other frames of reference which don't have the same velocity or that are moving slower than it. Okay, after this, we started with the Ted Sider, and we're still going to try now to finish up the works of Ted Sider today. Theodore/Ted Sider, he starts off by saying that it's difficult to question the nature of time, but we should do it because ordinarily we just take it for granted. But once we start to examine it in any kind of depth, we notice that it's very puzzling and our ordinary ideas of it start to break down. One of the things that he thinks is hard to explain about time is the common idea that time moves. People say of time that it flies, that it's marching on, that it's passing, that it's flowing. And in all these different ways, people express some sense of time moving. But he asks the question, what does it mean to say that time moves? That's actually a very vexing problem because the idea of motion itself refers to time in its own definition. How is it that things move? They move by being in different places at different times. And so if time moves, then on similar grounds, we would have to say that time moves by being in different places at different times. But this invokes the concept of time itself in the analysis of the term, which then makes the term circular and invites an infinite regress. To try and show the problem here, he displayed a diagram. In the diagram, there was a train that was depicted as moving from its origin in Boston to its final destination in Washington, D.C. And on the graph, we showed that it was moving by being in the different destinations at different times along its journey. That just provided a vivid graphic illustration of how anything that moves must change its position over time. And so again, this leaves us with no clear understanding of how time could move, because if time is in different places at different times, then what is the second sort of time that time is moving with respect to? Ordinary objects move through space with respect to time, but how can time move with respect to some other sort of time? That would seem to be leading to infinite regress. Another attempt, he said, could be to try and say that it is the present moment that is moving. So maybe time moves by means of the present moment changing its position. Initially, let's say right now, the present moment is 10:06 a.m. Earlier this morning when you woke up, I guess 8 a.m. or something was present. Now that's the past. Later today, 3 p.m., 6 p.m., 9 p.m., etc. will be present moments. But he says this also doesn't quite have any kind of explanatory value, because in showing a graph of the present moment moving, we show the present moment moving with respect to time-like coordinates, t1 through 4. And if those time coordinates are ordered in a linear sequence, then they would have to be placed in a broader graph to give them an ordered structure. Therefore, the idea of time moving has just completely tied us up into knots, and it seems like it's hopeless. Therefore, he says a better approach would be to completely abandon the idea that time moves at all and rather embrace the space-time theory of Einstein. Because according to that theory, time does not move. All events of the past, present, and future equally exist. They're all real. And time and space just sit there containing everything. Nothing's coming into being, nothing's passing out of being. So that's the alternative picture which allows us to escape this problem of explaining that time moves. To further enforce our understanding of what objects are like on the space-time theory, we were talked to about space-time diagrams. In a space-time diagram, you show the existence of an object as it's spread throughout its spatial but also temporal dimensions. The temporal dimension on the graph is like the horizontal axis, the T diagram, the T axis of the graph. And an object that extends through time because it endures over some span of time has a sequence of temporal parts that are stretched out along such a graph. What is a temporal part? Let me know this. That's a little question that I could ask the crowd. What's a temporal part of an object according to this philosophy we've learned? Someone just let me know and I'll see what you have. Okay, yes, correct, Sydney. It is an object at a single moment of time. So, for instance, one temporal part of you is hearing the words that I'm saying right now. But now a different temporal part of you is hearing a new word because each different moment is a different temporal part. So the sequence of moments, inclusive from the beginning of your existence all the way through to the end, all of these temporal parts equally exist, not just the one that is the present moment. And again, for each additional moment of time, there's a different temporal part of the individual or the object. These temporal parts are claimed to be just as much real as your physical body parts. In space, we have parts which are called spatial parts. Those are just the familiar parts of an object that occupy space. In the case of a car, one of its spatial parts are the wheels. Another part is the hood, the trunk, the cabin. With a human being, the spatial parts are the different body parts, arms, legs, head, torso, etc. Temporal part is the whole object in space, but just at one instant of time, like as you would see in a photograph of an object at a given particular moment. Now, from here, we were saying that there are three similarities between time and space. So to further deepen the understanding of space-time theory, we have to be able to understand how time is more significantly similar to space than we ordinarily assume. So let me try and get that back up on the board because this is where we broke off and ran out of time last meeting. So Ted Sider speaks to us about three similarities between time and space according to the space-time theory. So how are we to conceive of time if we embrace the space-time theory of Einstein? Much more like space than we ordinarily think of it. And so here are the three main similarities that are described. Number one, similar in terms of reality. Time and space are similar in terms of reality according to the space-time theory. A second similarity between space and time according to the theory is in terms of parts. And then the third mentioned similarity from the author was in terms of the words here and now. Okay, so I'm going to walk you guys through the three mentioned similarities by the author so we can understand this together. Starting with in terms of reality. So what this is talking about is this. Objects in space, when they're far away from you in space, they're just as real as when they're up close to you in space. And the same exact thing is true of events in time. Okay, so let me write it. Objects that are far away in space are just as real as objects that are close up in space. And the same is true of events in time. Okay, so objects that are far away in space, just as real as objects that are close in space, and the same is true of time. Okay, so let's consider how when an object is close to you or far away from you, this makes no difference to how much it exists or whether it's real. So consider this marker that you see in my hand right here. I hope we could just agree that this is not an optical illusion or a hologram, but this is a real marker. It is, and it's real, and it's in my hand. Now, I hope this is an easy question. I'm just going to set you up for like a real home run. If I leave this marker right here, and then I create space between myself and the marker. So right now it's like whatever, like about a foot away from me. But what if I walk 10 feet away and leave the marker behind? Is it still real? Because now it's farther away from me. But does it still exist? Yes, of course. What if I leave this marker here in this classroom and I drive all the way home to Long Beach, like whatever, 20 miles away? And now we're 20 miles apart. Right now we're 1 foot apart. Then we're 20 miles apart. Is it still real? Sure, it is. And I hope you guys understand that no matter how many ways I ask this question, the answer is still going to be yes. What if I leave the marker on the planet Earth and I take a trip to the moon and I'm an astronaut? I'm millions of miles away, let's suppose, from the Earth. The marker's back here, but it's still real, you understand? Or maybe I fire it to the moon. That'd be easier. Or maybe not. But anyway, I stay on the Earth, fire it millions of miles away, put it on the interstellar space Voyager, and it's outside the Milky Way galaxy or something. No matter how far away it is, the point is it's still real. So objects that are up close to you, like the clothes that you're wearing right now, they're real, but so is the moon, even though it's much farther away. So in terms of space, spatial distance doesn't affect reality. It's not like things are only real when they're close up to your face. They're just as real when they're far, middle distance, or any distance. Now, the similarity here is this. According to the space-time theory, events in time are just as real, no matter how far no matter how far away they are from the current moment in time. So right now, I know you understand that this present moment is happening because it's here. So you're watching a lecture, I'm giving the lecture, and this is what's now. But what about your last birthday or something? You might look back at that and think, well, that's over with. That's gone. Only what's happening now is real. On the space-time theory, that's false, though. Your birthday back then, your birth, the dinosaurs, everything that's ever happened in the past is all real, and it still exists. And all the future events way out ahead of you in time, they're just as much real as the present moment is too. So you getting married, graduating Chapman, having kids, I don't know, retiring, starting a business, traveling to places you've never gone. All those future events are just as real as what you're experiencing right now. On the space-time theory, you have to just disabuse yourself of the notion that there's only the present and the future is open and the past is gone. On the space-time theory, in a way, nothing's open. It's all closed. The past is like the future because it's set forth and it's nothing that can be done to change it, and it's objectively real. So this idea is that space and time are similar no matter how far away an object is in space or how distant an event is in time. It's just as real as the things that are happening here and now. So objects that are present in space, like present to you in your immediate environment, are real. But objects are also real when they're not present in space, when they're far removed from you in space. Events that are present in time are clearly real. I'm sure you don't doubt that because this is now. But even the events that are distant in time are just as real as the events that are present in time. So spatial or temporal distance doesn't affect how real things are according to the space-time theory. So that's kind of strange, but it's a fact that's implied by the theory.
That's oddly comforting.
Maybe it's comforting, because sometimes people think, well, it's not comforting because I want to believe that I have total free will and an open future. On the other hand, though, a lot of people believe in God and religion. And if you believe in that, they also say God has a plan for everyone. So just trust God and there's providence. So whether it's scientific accounts of the nature of reality being governed by the laws of physics, or whether it's a religious account or some combination of both, there's definitely room to believe in fate, predestination, and all of that according to science or religion. But anyway, I digress. So events that are far away in space or time are just as real as the present moment in space or in time. When we talk about events that are far away in time, we sometimes employ spatial metaphors in language. Like when you talk about the past, sometimes you say, hey, remember back then, like back in the day, back, like behind me almost, as though it was behind you in space. And when you talk about things that are lying ahead of you, even that's a spatial metaphor. What's ahead of me? What lies out in my future? What's going to be out there ahead in the future, as though it's some directional, spatial direction ahead. But anyway, just as with space, how far back or how far ahead something is, it's just as real as the things that are right with you. Sydney, yeah?
So according to this theory, could you still say that we move through time?
Well, the temporal parts don't move, but the space-time worm, I guess, has parts and segments that are extended throughout time. But I don't know if it'd be right to say there's movement. No. There's no movement. What you are right now, one of your temporal parts is talking to me, or a couple of them, I guess, because there's many moments during this meeting even. But all the future temporal parts ahead of this moment, like whatever happens to you after this class or semester is over, they're also real. So, sorry, to return to your question again?
I was just saying, according to this theory, can we still like define us as moving through time?
Moving through time. Yeah, it's probably not the right way to say it because movement implies that one and the same thing is changing and going through stages, but all the stages are already there. So we'll get back to your point though in a moment. It's a good question actually, so hold on to the thought because I have something to say about that once I finish with this. Okay, so in terms of reality, objects and events are just as real when they're far or close, whether that's space or in time. Now, the second similarity here is in terms of parts. And what that is all about, according to the author, is that objects occupy space by having the spatial parts that they have. And objects occupy time by having temporal parts. So that's the similarity. Objects they take up space by having spatial parts. And objects take up time by having temporal parts. And in the space-time theory, both of these kinds of parts are just as real as each other. So I'll explain a little bit more in a moment here. Just write it down. Okay, so it says there, in terms of parts, another similarity between space and time. The similarity is that objects take up space by having parts in space, spatial parts. And objects take up time by having temporal parts. Now, spatial parts are just the physical parts of an object that take up room. So if it was a chair, you would have the legs of the chair, the back of the chair, the top surface of the chair, different parts of it. As I said before, for a human being, anatomy, hands, feet, arms, legs, torso, head, those are spatial parts. So the body parts, your spatial parts, are the reason that you're taking up space in a chair right now. And that's the reason that no other object could occupy the same chair, because your physical body parts crowd out the space for that. Now, objects also occupy time on this space-time theory, and it's just according to common sense. So objects occupying time is because they have temporal parts stretched out through time. So what accounts for the fact that you have mass and volume and a certain weight? The amount of spatial parts that you have. What accounts for the fact that you endure through time, like 20 years, 30 years, 100 years, however long the thing exists? That is because you have a series of temporal parts that are aggregated in a sequence across the moments of your existence. So objects take up space by having spatial parts, and they take up time by having temporal parts. A temporal part is the same physical size as the whole object, but in terms of its time size, it's just an instant, a split moment. Look at your right hand, and I know you believe it exists. It's right there in front of you. So no doubt there. You're supposed to have the same type of total confidence that temporal parts of you in the future and past are as real as your right hand, if you accept this theory. So it's telling you that that's a similarity. And now a third similarity is this. In terms of the words here and now, here's how those are similar. Put the colon in the wrong place, sorry. In terms of the words here and now, they're similar because they're both relative terms. And the meaning of both terms depends on the context of the speaker. So both are relative terms. Whose meaning depends on the context. They're relative terms, so they depend on context. They don't have an objective meaning, but the meaning does depend on the context of the speaker. Okay, so I'll write that of the speaker, and now explain. So it says, in terms of the words here and now, how are those two similar things? Both are relative terms. Here is a spatial word that's relative. Now is a temporal word that's relative. So let's go into that. Here's a question. Oh, you say take up instead of occupy. I kind of agree with you, Cordy. Let me see what you've written. Take up could be constructed as implying movement in some way, couldn't it? Occupy seems like the better word. So funny. You're very sharp. I had a thought about that because in the previous hour from 9 to 9:50, I wrote the definition as occupy. And then I thought, are some students going to be confused by the term occupy? So you've, in a way, helped me to justify my own prior intuition that that was the better way to say it. So it doesn't matter that much to me because they both express a similar idea, but I take the point. So if you want, you can revise that to just say occupy, because perhaps you think take up means like it's moving or something, and it's an action type of verb, whereas occupy is more passive sounding. So I find no problem with that. But it doesn't really change the overall understanding much. But thanks so much. Back to this, though. The words here and now. Okay, so here's a question, kind of a little trick question. Where is here located? Where is a place called here? What part of space is referred to with the word here? Where is here at? What's the definition of here? Is there one single place that's referred to by all people as here? Is there some place on the map where if you have a globe, you'll see here written on that globe and you can pinpoint it? No. So where is here then? What would you say? Well, hold on a moment, because you're saying present moment. That has more to do with now. We'll get to now in a second, but here is a spatial word. So where? What's the location? Okay, so Zoe, you say this. Here is the area in which it's spoken. Good. And Cordy, you added, it's relative to each individual. Sure. But it's relative to the context of speech. Okay, so for example, if I say here, it's pretty quiet in Argyrios Forum. Well, I'm referring to the place where I'm speaking because I'm in Argyrios Forum right now. So in here, there's like 3 students in the room. But in your case, those that are watching on live stream at home, you would not say that here I'm in Argyrios Forum, or that here there's 3 other students or 2 other students in the room. Now, who's correct? I say here there's 4 people in the room, and you say here there's not. I'm assuming, right? Well, are we contradicting each other? No, because my speech act of here refers to the place where I am when I say it, and I am in Argyrios Forum. It's the same thing like this. Suppose I had a phone call with a friend that's on the East Coast, and I said, over here we have Governor Gavin Newsom, and he says, here it's Governor Andrew Cuomo. Well, are we contradicting each other? Because we're saying here there's 2 different governors. Who's the governor of here? Well, here is not one place, obviously. In my speech act, as the person talking on the West Coast on the phone, here refers to my current location and state. And in his speech act, on the other side of the phone call, his word here refers to his local, current environment, which is New York. So the word here doesn't have a single objective reference. Where it is depends on where someone says the word when they say it. Now, the same is true of the word now. So now we'll get to the second part of the comparison. When is the moment called now? When is now? Well, I mean, right now, it's 10:25 a.m., I guess. When you're watching this later, you guys watching replays, it won't be anymore the same time and date. But when is now? You have to give a more convoluted answer. You can't just say a time. So when is now exactly? You said it earlier, though. Now you don't want to say it again. When's now?
That moment in time.
When the person says it, right? Exactly. So if I say, I'm teaching a class and I say, okay, now we're going to open our books. And I'm speaking in the year 2021. So I'm referring to that time and place when I say it. If there were people 100 years ago studying Einstein in university classes, and they're like, hey, everyone, let's study this current day living, amazing young physicist, Einstein. Now we're going to study that. They're not talking about 2021, but they're talking about 1921, the time that they spoke. And if in 100 years from now, people are like, hey, let's all study the early 21st century. Wasn't that crazy when they tried to have a coup to overthrow the election, and when there was a pandemic going around and social media was coming out? Look back at that time now. They're not referring in their speech to the year of 2021, but 2121 when they would be speaking those statements. So the one word now does not refer to some privileged and objective point in time. And for a lot of people, that's kind of like a shocking thing to think about, because when you think of the now, you do think that it's actually absolute. And there's only one now, this moment. And all the other moments in comparison can't be now. But what you're hearing from the space-time theory is that now is a relative term. And so in the speech of a 1921 person, now is 1921. And in the speech of us today, now is 2021. And the speech act of a person saying now in a future time, that's also now. So it's not like any different than here. There's no privileged position on the planet that's called here or in the universe. It depends on where someone speaks. Same with now. There's no single uniform moment of now. It depends on where in space-time the speaker speaks the word now. Okay, so with these similarities been advanced between space and time, he says we have a better fix and a better understanding of what the theory really implies and what it means. But to finish his discussion, he adds this. He says some people, though, will still want to resist this idea because it's obviously counterintuitive. You know, what you're being told is that all the moments of space-time exist. There's not just the now, and all the full future and past are just as real as the present. I mean, that's a big, heady conceptual revision of common sense. So some people reject that, and they say things like this. It's just too much contrary to ordinary, everyday common sense. And someone might say something like this. He has a quote from an imaginary critic. He says, a person may say this. Past and future objects do not exist. The past is gone. The future hasn't happened yet. Things do not have temporal parts. At each moment, the whole thing is present, not just one temporal part of it. There are no past or future parts left out. Now is not like here. The present moment is special. It's not like the relative space around you when you say the word here. So some people may reject these things because it violates intuitions that we have from common sense. But I find that the most often category of a person who doesn't like these ideas or rejects them is not really a scientist, but often a philosopher or just a common person, because in science anyway, this is a consensus view. And as strange and weird as it is, it's accepted. But there are also some other counterintuitive points that could be raised about it. And here's one more that I'll close with on Ted Sider. Then we'll move to David Lewis. One more tough issue that advocates of the theory have to grapple with is that according to the theory, nothing ever really changes. And I think this kind of speaks, Sydney, to what you were saying earlier indirectly. So hopefully that will kind of come back on into the mind now. So let's try and understand this. According to the space-time theory, nothing ever changes. Okay, so I want us to try and reason our way through this and think about it. According to what you've learned and what you're starting to know about this theory of space-time, why do you suppose that someone would say that based on it, nothing actually ever changes? Because it's already there. That's one way to put it, Sydney. You can type it in the chat. Let me add to your comment, but with an example. So suppose that there's a person who gets a haircut. Simple. They come into the hair salon with long hair, and they want to change up their look or whatever. So they're going to get a short cut. So they get this short haircut. Now, you might look at that and say, they have changed. Their appearance has changed. They've changed their look. Time A, entering the salon, long hair. Before and after that, later after the haircut, short hair. So they've changed. But on the space-time theory, it's not actually correct to say that anything has changed. And why not? What would be the real reason that nothing has actually changed despite appearances? And kind of, Sydney, you hinted at it, but can you give or anyone, a detailed explanation or a more detailed explanation as to why this doesn't count as change? Well,
person's conscience, their torso, their body, everything, a part of them, their heart, their mind is the same. It's just they're just different. Like, love doesn't mean that that person has a different mind or.
No, it's not getting deep enough, my friend. It's not getting deep enough what you're saying. You're saying that their heart and consciousness and the essentials of them have not changed. But even the fact that the hair is different in appearance, that hasn't changed either. Why not? Well, you'll be thinking about it.
It was already there.
It was already there. All the temporal parts all have existed at all times throughout eternity. So look, Dennis, space-time diagram. Here's our vertical axis, X, horizontal axis, Y, and the time dimension, T. Suppose a person is born in 2003, like maybe you were, and then they live till 2100, like maybe you. Okay, so I'm drawing these little stick figure shapes to show the development and existence of the individual throughout all these moments of time that they exist. And let's suppose that we have this time marker for when the haircut happened. This is the time slice. And then there's another time slice after that where they've got the shorter hair now. Dennis, The entire sequence of events has all existed the whole time. So these 2 points on the timeline don't pop into reality when the haircut happens. That point in time space where they have short hair has eternally always been there. Same with the point in time space where the long hair has always been there. This idea that the present moment is not the only moment, that's what I think is the stumbling block for you. The past and the future are as real as the present. So like you, graduating Chapman, exists now. You, having kids, starting a business, getting retired, exists now. And so you might look at that when it happens and say, something changed. I didn't have a degree, now I have a degree. So I'm a degree holder, I've changed. There's not been change because the degree holding part of you, the physical body and everything exists. It all exists. You sitting in this chair right now is not the only part of you that exists. All the past parts of you from a baby on till now, they're that part of the timeline, and they're still in the timeline. And all the future parts of you after this meeting, they're all in the timeline too. But the whole timeline hasn't changed. The whole timeline just sits there with all the stages included within it. And so it's an illusion, the appearance of change. What you're really seeing is 2 different, what are they? 2 different temporal parts of the same object with different qualities. So time t1 temporal part had the long hair. Time t2, second temporal part after that, had the short hair. But the 2 parts are all located on the same larger structure of the space-time diagram. Yes?
But what is change if not one moment going to the next?
Well, okay, now that's a good point. So what the author says about this is the following. He says, to some, this is a bridge too far. They're like, my common sense cannot accept that nothing changes and that all the objects with all their temporal parts are just located in space-time and that's it. Some people might reject that, but Sider says this.
So it's because the temporal parts aren't exactly the same, that's the bottom line.
They're not exactly the same.
Or not exactly the same.
Well, no, these 2 are not because we're talking about a haircut. Like you, for example, yesterday you weren't wearing that sweater, right? So that temporal part of you still isn't wearing the sweater because it's in the past. And this temporal part of you is always going to be wearing the sweater. Even in the future, this part of time will continue to exist. And you will still be this part sitting in this class watching this forever. It's kind of like you're never going to die in a way. It's weird. It's weird stuff. Because that means that all the temporal parts don't go anywhere. I've heard weird views, like metaphysical speculation as to how to ground the idea of like personal death with this eternalist picture. On space-time theory, we replace what's called presentism with eternalism. Presentism is the most everyday common sense way of thinking about reality. According to presentism, there's just a single present moment, this moment, and the past is gone, and the future is wide open, and it has not happened yet. But space-time theory says that is false. It's all closed. The future is closed just like the past because it's already happened. Now you're starting to see the picture? It's a bigger picture than what you're saying when you say person gets a haircut, but they're still same person, like they still love music or whatever, even if they got a haircut. That's not what we're talking about. We're talking about the whole person, the stage of the person in the future existed before the haircut happened. Okay?
So does it predict death to them?
Huh?
When you die as well?
Well, it's not a prediction. I mean, it's already happened. You keep talking about the future as something that's open. Hmm?
Did you ever watch Doctor Who? This is a little bit like that. You should watch
Watch science fiction stuff. You'll get it. And you'll,
Yeah.
Mine is just like,
you gotta break open that mind and like completely.
Basically, you already done it. So.
Yeah. Well, but you've also been born.
Like
So.
time travel. Time travel. If you were to travel back in time, nothing really.
Let me get back into what I'm saying here, guys, on the chat. Okay, let me just make this very clear. The concept here is that nothing has changed. What we would call change, to answer your question there, is rather qualitative difference among different temporal parts of an object. Okay, so like one temporal part had the long hair, a subsequent part later on in the sequence has the short hair, but the parts themselves have not gone through any change. They just occupy their position in the timeline, and they always will, and they always have. One last example to try and drive home this point here. Take the metaphor of a road. Here's a road. Suppose, so like there's the road divider. We got a car driving along this road or highway. Suppose that at the beginning of the road, it's nice and smooth. But as you continue the journey and you get later on into the same stretch of highway, it's got a lot of potholes and cracks. It becomes a bumpy road over here. Now, the person who drives through this path, they may say, the road really changed. The road changed a lot. It was smooth, and then as I continued driving, it got bumpy. But in a way, it's not perfectly accurate to say the road has changed. Rather, you're experiencing different parts of the road at these different times. you can say that the whole road altogether has always had these features. The beginning part has always been clear, and the latter part has always been bumpy. So what really has happened is not so much that the road has changed, it's just the position of the observer on the road has seen different parts of it. And so now by metaphor, you're the road itself. And the sequence of stages in your life all exist somewhere along this timeline. When you see a new event happen, like you get a black eye, or you have a new outfit on, or you get a haircut, it's not that it's happening for the first time and something has changed. It's just that you, the observer of your life, see that temporal part that you did not see before. And so the whole road exists with all its features fully laid out, but the observer zooms around and sees different parts of it at different times. Okay, so that's about it for the Ted Sider. The last thing he says is that, well, if time and space are truly similar to each other, as the theory says, then we should expect it to be a theoretical possibility for there to be time travel. Because objects can move in space in any direction, or they appear to be able to do that. So why shouldn't it be possible to have backwards time travel, forwards time travel? Well, forwards time travel is definitely theoretically conceivable because all you have to do is accelerate something much faster than other objects, and then it's going to time dilate, and the time it experiences is going to be much less than the time experienced by all external clocks. So in that case, you could go to the future if we could manage to master those forces, which I don't think is possible, but theoretically conceivable. Backwards time travel will be much harder to do because, okay, according to space-time theory, all the moments of the past still remain in the universe. They're still in part of space-time. So in theory, we should have access to them, but we would have to bend and warp space-time using like wormholes or black holes. And these are the kind of things that I don't think any person could ever survive, nor could we invent the technology to achieve it. But it's a theoretical possibility. And that's going to lead us to the next author and the final author on this topic. So the last one is David Lewis, and his paper is called The Paradoxes of Time Travel. So he wants to explore more deeply that specific concept. David Lewis, American philosopher of the 20th century. He's definitely one of my top 5 kind of favorite philosophers overall. He takes on a lot of weird and neglected hypotheses and gives like very clear and robust, detailed argument in favor of those kinds of things. This is a paper he wrote when he was pretty young still, 1976. Actually, it was originally 1971 as a lecture and then published 5 years later as an article. So he's 35 at that time, and it's called The Paradoxes of Time Travel. Okay, Paradoxes of Time Travel by David Lewis from 1976. Now, his goal in this paper is actually a seemingly simple one, or at least I don't know if I should say that, but the thesis is straightforward. The thesis he has is this: time travel is possible. It is possible. It's conceivable. It's not impossible. And he has to defend this position because a lot of people who examine the idea make the case that it involves perplexities and paradoxes that just make it inconceivable and logically inconceivable. But he says, no, it's not impossible. The weird so-called paradoxes of time travel, hence the title, he says they're just that. They're just weird, but they're not literally impossible things. So his goal is to try and make the case that time travel is not impossible. And as he does this, he's going to walk us through what are some of the major claimed paradoxes of time travel and try to dismiss them as showing that it's not possible. So let's get into it. And his first thing to do is to try and define the idea of time travel to the reader. And he has an interesting definition of it. So here's what he says. Time travel just is a discrepancy between 2 different measurements of time. A discrepancy meaning like a difference between 2 different measurements of time. Okay, so to help explain the given definition here, let's imagine this situation. Here's a person. This person is going to walk into this cylinder type receptacle. And then they're going to get out of that after some amount of time inside. Now, suppose that when they walk into this here thing, they get in and it's 1 p.m. on their watch, okay? On their own personal wristwatch. Suppose that on their same wristwatch and according to their experience, they spend 5 minutes in there. So you follow me? They get in, it's 1 p.m. 5 minutes goes by and they get out. Now, try and follow my line of questioning. Suppose that when this person gets out of the machine or cylinder, I don't want to say anything, when they get out of that thing, all the clocks outside say 1:05 p.m. on the same day. If that's the case, did this person time travel or no? If the person walks in at 1, spend 5 minutes on there according to their watch, and they get out and all the watches everywhere say 1:05, was that real time travel or no? No. Okay, in that case, they didn't walk into a time machine. They walked into a shipping container, hang out, and their 5 minutes, get out. And that's not real time travel. Or if it is, then we're all, I guess, time travelers, but in a very boring sense, meaning that we all time travel from the past to the future at a steady rate of 1 hour per hour. But when we talk about time travel, we mean like jumping ahead or jumping back. So let's think about this. Suppose that he has jumped ahead, bless you. Suppose that this man has traveled 2 hours to the future, a little short time travel situation. He gets in, and on his own watch, it shows 5 minutes have passed. So when he gets out, it says 1:05 on his watch. But if this was 2 hours to the future time travel, then what should all the external clocks say when he emerges from the cylinder? They should say 3:05, correct. Because that means that 5 minutes of his own time was equivalent to 2 hours for everybody else. So that's like hopping 2 hours into the future just on a 5-minute time spent in the machine. So that would be the equivalent of 2 hours to the future if all external clocks say 3:05 p.m. So let's suppose that is the case. Well, one more thing. Let's talk about going to the past. Suppose this man actually takes a trip to the past and he goes back in time 2 hours. So he gets in at what appears to be 1 p.m. on his watch. 5 minutes surpass on that same watch, but he exits from the machine and he's gone 2 hours into the past. So what time did the external clocks show in that case? Yeah, like 11:05 a.m. So it's like it looks as though he gets out of it before he ever walked into it. To all people outside of the machine, they will just see a guy emerge from the machine at 11:05 and wonder how he got in there. But anyway, the point then is that if it's time travel, then the duration between when he gets in and when he gets out has to be separated by 2 different intervals of time. On the one hand, it looks like how much time did it take him? Let's go with the 3:05 p.m. case. How much time does separate him getting into the machine and getting out? It looks like we have 2 possible answers. What's one answer to my question? How much time in between getting in and getting out? How much time between getting in the machine or cylinder and then emerging from it? If we say that he enters at 1 p.m. on his watch, spends 5 minutes according to that watch, and gets out, but it's 3:05 p.m. on everyone else's watch. One way of looking at it is that how much time was in between getting in and getting out? 5 minutes. Does that make sense, Dennis? Because, right, he gets in, it's 5 minutes when he gets out, according to his watch. But another answer suggests itself too, right? The other possibility, from the point of view of all the other observers, not the time traveler themselves, it would appear that they got in at 1 and got out when? No, come on. You can't, well, look at the numbers. So another possible answer is that he didn't spend 5 minutes inside, but how much time? 2 hours. What's the difference between 1 and 3:05? So it's 2 hours on another account. So what's the right answer? Was it 5 minutes or was it 2 hours? It looks like it's both. And to some people, that already is a paradox. So now I'm going to list the first possible paradox of time travel that he's going to try and bat away and explain. So here's the first possible paradox. How can the same 2 events be separated by 2 different amounts of time? Unequal amounts of time. Okay, so if entering the machine is event 1 and exiting the machine is event 2, we have an inconsistent pair of answers as to how much time separates those 2 things. One way of looking at it is that it's 5 minutes because that's the personal amount of time the individual experienced in the machine. But since it's a time travel machine, when he gets out in all external clocks and observers, it's 3:05 p.m. So it looks as though it's been 2 hours according to that other measurement of time. Now, ordinarily, when we ask a person how long something took, yeah, so Angel, because 5 minutes would be equivalent to 2 hours and not 5 minutes on top of the 2 hours. Angel, let me see. Oh, sorry. Wait, so he would not get out at 3 instead of 3:05. perhaps, Angel, I didn't want to be too picky on the math between 3:05 and 3. The basic idea here is there's a 2-hour gap in the experience of all people that are not the time traveler, and there's a 5-minute gap in the experience of the time traveler themselves. But thank you for being precise and a little bit picky on the 5-minute thing. It's not too important to me. So if you want, you can modify that to make your notes consistent and say 3 p.m. But anyway, when people say, how much time did something take? Normally they think you're only going to be able to give one answer. What if you had a friend that flew in from New York, they touched down over at John Wayne Airport or something here in Orange County, and you're like, hey, how was the flight? They're like, it was a great flight, it's very smooth. You say, okay, how long did it take actually? And they say, how long did it take? Okay, well, it took 90 minutes and it also took 6 hours. You'd look at the person like, are you losing your mind? I asked you how long it took and you gave me 2 different amounts. So normally you would think that's not possible. In this situation though, that's what's implied by the time discrepancies between the external observers and the individual. So how to solve this problem? Well, David Lewis says problem solved by introducing 2 different time frames. So we have these 2 time frames. What's called personal time and external time. So personal time is time as it is experienced by the individual time traveler as measured on their personal wristwatch. Okay, time as experienced by the individual time traveler and as would be recorded and measured on the personal wristwatch that they keep on their wrist, which travels with them. External time would be time as experienced and measured by all external observers and clocks. That are not basically the time traveler or his own watch. So now actually we have a more careful answer to the question how much time separates the 2 events. So as we close the meeting here, let me just see if you can put this last piece together. The right answer to our question, how much time is in between getting in and getting out of the cylinder? We would say that it's 5 minutes of which kind of time? So personal time, it's 5 minutes of his own experience and according to his own watch. But it's 2 hours of external time, because on all external clocks, it shows that the gap between entering 1 p.m. and exiting 3 or 3:05 p.m. is roughly 2 hours. So we actually can have it both ways once we introduce 2 different types of time. And an implication of the space-time theory is that each object does have its own personal time frame. The only reason that they don't diverge from each other is because we cannot achieve variable speeds of the kind that would be necessary to make the effect noticeable on the planet Earth, given our technological limitations and so forth. But if objects could accelerate much faster than others, then we would see huge differences between personal and external time happening all the time. And in fact, this is achievable by means of tiny little elementary particles, as I've said before. So problem solved. It's not impossible, therefore, because personal time can be different from external time, and this would be predicted and expected in case such a device as a time travel machine were to be constructed. So one paradox he thinks he's safely dismissed, but there's a couple of others that also have to be addressed. So we'll finish this, take about 15 minutes at the beginning on Friday, and then on Friday we'll start with the next topic in the class, which is philosophy of mind. So I would ask you guys to go ahead and try to read Descartes' 6 Meditations for the Friday meeting, and also David Lewis's article if you haven't already, and then that'll be our plan for that day. And I'm going to also distribute the second essay prompts in the next few days, so we'll be in touch over Canvas about that. All right, guys, so I'm going to have to close our stream and let you guys go, but let me see if everything's okay, and if you're good to go and you don't have any questions for now, then I'll just close it up. So just a second. Okay, thank you, Zoe, Cordy. Appreciate all you guys' hard work, and focus on the class. I hope your semester's going well. I'll see you then on Friday, and again, let me know if there's anything I can do or that you need. All right, thanks so much. Bye-bye.